Okay, forgive me, I was just interrupted by a board member he's a good friend of mine, Mr. Decker, and we were in the middle of this problem, so let's go ahead and solve it here. I'm going to subtract 3x from both sides, so I get x is equal to 6. Now, one thing about proportions you need to do is you should always check to make sure they work in the problem. So if I have a 6 here, that's 6 plus 2, that's 8, it works. So that would be a valid answer. Now, I'm going to do the same thing here again. I'm going to do the product of the streams equals the product of the means. So I'm going to go 5 times the quantity x plus 1, don't forget the parentheses there, and don't forget to distribute, equals the same thing as 3 times x. So when I do that, I get 5x plus 5 is equal to 3x. Go ahead and subtract. I'm actually going to, let's go ahead and subtract 3x from both sides. So I get 2x plus 5 is equal to 0. Can I subtract the 5 over? Yeah, I get 2x is equal to a negative 5. Divide by 2. Divide by 2. X is equal to a negative 5 over 2. So it's not hard. And look, it's a fraction. And I plug it in. It's okay. I won't have 0 on the denominator of the fraction, so it's okay. But let's keep on doing it on this one. We also have another proportion. And again, if I do the product of the extremes equals the product of the means. Does it matter if you put the means first or the extremes first? No. In fact, I'm going to put the means this time first. I'm going to go x times x, those are my means, equals the product of my extremes, 2 times 32. So when I do that, x times x is x squared, equals 2 times 32, which is 64. Now, I'm looking for what x is. Well, this is not a geometry problem, this is an algebra problem. So when I take the square root of both sides, what can I not forget to do? Put your plus and your minus down. So x is equal to plus or minus 8. And when I plug them in, they both work. Positive 8 works. 2 over 8 is 1/4. 8 over 32, 1/4. 2 over negative 8 is a negative 1/4. Negative 8 over 32 is a negative 1/4. So it works either way. So you have to have both ones. Now we're going to do some properties of proportion. I love these. They're so easy to do. There are just going to be 3 of them that we use. We could make up a whole bunch of combos of those. I'm going to give you the generic one. I'm going to give you the example with one, and then I'm going to tell you the names of it. Okay? Now the generic proportion we're going to go is A is to B as C is to D. A and D are my extremes, B and C are my means. The first property that we do does the following. It goes A is to C, and I'm going to move C, as B is to, oops, I meant to say B there in red. B is to D. Now, what did I switch here? That's right, I switched the means. And that's the name of the property. Switch the means. And the cool thing is, I can do that here, and I still get a true proportion because my products, my cross products, stay the same. So I go here, and I go x is to 3 as y is to 5. Those switched locations. So that's where it came from. Kind of cool. All right, now go back to my original one again. A is to B as C is to D. Now look at this next one. I'm going to get D is to B as C is to A. Now this time what switched? Yeah, that's right. My extremes switched. So that means if I did this next one, I'm going to have the extremes switching. Those are those two. I'm going to get 5 is to Y as 3 is to X. I switch this time the extremes. So it's switch the extremes. Okay, I think this is my favorite one. By hands down, I think it's my favorite one that we're going to do. It is called invert. Literally, I flip everything over. B is to A as D is to C. Notice B and D are still here, A and C are still here. Everything just flipped literally over. It's called invert the proportion. Because again, if I did my cross products, I would come up with the same thing. The cross products would still be true. So on this next one, if I get x is to y as 3 is to 5, and I inverted it, I get y is to x as 5 is to 3. So it flips the whole thing over. All right, let's get our last one here, and this one's kind of fun. And I know it's me being nerdy, but I think this is a lot of fun. Okay, when we're doing this one. It is actually the following. A plus B is to B as, and I'm going to circle what's the difference here, I have a plus here, as C plus D is to D. Now when I do my cross products, these still work. Now let me show you in a second how that works, but I think it's kind of cool. This is called add the denominator. But you notice you add the denominator both to the denominator of each one to the numerator on that side. You don't add it to the other one. So that would be the following: of an x plus y is to y as 3 plus 5, which would be 8. So you could have said 8 there, is to 5. Or you could say x plus y is to y as 8 is to 5. Either one of those would be the same thing. Now let me show you real quickly why this works. I'm going to cross multiply, okay? I'm going to get d times a plus b equals b times c plus d. And I'm going to distribute these. So I'm going to get a times d plus b times d. You do it in alphabetical order when you do these. You get b times c plus b times d. Now, I'm going to subtract b and d away from each other. So it's minus bd, minus bd. Oh, look. AD is equal to BC. Oh, what's my cross product? AD is equal to what? BC. My cross product did not change. Isn't that like the coolest mathematical thing ever? Okay, we're going to use that now to the next page, but we're going to stop the recording here and I'm going to flip